This section is all about geothermal power, which is the capture of heat energy from beneath the Earth's surface in order to produce electricity or provide heat. However, before we discuss how we use geothermal energy, we need to understand some basic principles of geothermal energy itself. The Earth's internal heat emanates from its core, causing the gradual liquefaction of deep rock layers into molten magma. This molten substance may eventually erupt as lava flows on the surface or give rise to geysers and hot springs. A significant portion of this thermal energy remains beneath the Earth's surface, steadily warming the surrounding rock and water as much as 370 degrees Celsius. In instances where subterranean water pockets are subject to this heat, it can result in the capture of hot water or steam, forming a geothermal reservoir. This geothermal energy, harnessed from these natural heat sources, can be utilized for the generation of electricity or for providing heating purposes. Geothermal energy is harnessed by tapping into underground reservoirs of hot water or steam. To generate electricity, wells are drilled to access these reservoirs. Fluid is pumped into these areas until it becomes superheated, and this superheated fluid is then brought back to the surface. The heat energy from this fluid is used to turn a generator, which in turn produces electricity. Afterward, the water is cooled and returned back into the reservoir. Additionally, geothermal energy can be used for the direct heating of buildings. The potential for geothermal's energy varies from one region to another, and it is notably higher in areas located near fault lines. These fault lines play a crucial role in allowing geothermal heat to reach the Earth's surface, thus making the harnessing of this energy source more accessible. Regions characterized by significant seismic activity, such as Iceland, many areas along the North American Pacific coast, and California, exhibit high geothermal energy potential. California, in particular, stands out as a major producer of geothermal power in the United States, primarily owing to its numerous large fault lines, which facilitate the extraction of geothermal energy. There are just a few environmental considerations when it comes to geothermal energy that need discussing. First, direct heating applications of geothermal energy have almost no negative impact on the environment. Geothermal power plants offer several benefits. They do not burn fuel to generate electricity, resulting in very low emission levels. Moreover, they trap some greenhouse gases underneath along with the superheated water. However, there are challenges associated with geothermal power plants. They can release small quantities of polluting gases, including ammonia and hydrogen sulfide. These plants also depend on groundwater recharge, which means they can run out of water if used faster than it can be replenished. And that completes our short discussion on geothermal energy. In the next section, we will be covering a lot of ground as it pertains to biomass energy.